Okay, in this video, I'm going to be doing an example that's kind of an amalgam of everything that we've been learning before. So it's going to be a psi function with an infinite ordinal in the subscript, as well as a regular number, and it's going to go through pretty much all the other rules that we learned before. Now, a point of interest, we're going to be diagonalizing to 2 instead of 3. And the reason for this basically is that when you use 3, these things get complicated very, very fast, and we can't get that far into our deconstruction. So to get further, we're going to use a 2, basically. So some of the things that happen when you diagonalize to 2, for instance, if you have psi of 0, which we know to be epsilon naught, diagonalized at 2 is simply omega. And then that just turns into 2. So when we had before, like omega squared times 2 plus omega squared plus 3, when you diagonalize at 3 with 2, it just equals 2. So that simplifies things quite a bit. Another thing that happens, let's say for instance we had psi 1 of 0, which translates into psi epsilon omega plus 1. When we diagonalize at 2, we get psi omega to the omega. And let's say we take that and we want to diagonalize that now. If you remember before, what we did was we took a fundamental sequence of psi of 0 and then plugged this guy here into here. And when we diagonalize to 2, basically, this is as far as we need to do. So we just take the second element of the fundamental sequence. So this really equates to just taking this guy here and replacing it with psi of 0. So that simplifies things quite a bit. I'm going to use these properties, basically, in this deconstruction. And I wrote it out previously just because it's a little bit tedious writing all these towers and stuff like that, and I don't want you guys to have to watch me tediously write everything out. So I just did it previously, and we'll just go through it, and I'll explain along the way everything that I do. Okay, so we basically start out with psi omega plus 2 of 0. So the first thing we're going to do is we're going to take the previous psi function to this and then plug in the limit of where this function runs out of power, basically. So it's going to be psi omega plus 1 of epsilon omega, or omega plus 1, sorry, yeah. And now when we diagonalize this to 2, using this rule over here, basically, we get a tower of 2 omega. So this turns into psi omega plus 1 of omega to the omega. Diagonalizing again, we just replace this guy here with this psi function of 0. So we end up with a psi omega plus 1 of 0 in the superscript right here. So now we have another psi function with a 0 here. So we can once again take the previous psi function and then take the point where this runs out of power. So it's going to be the psi omega of epsilon omega plus 1. And once again, when we diagonalize this guy here, we just end up with a power tower of omega's too high, which is this here. And then when we diagonalize this again, this turns into a psi omega of 0, which we get right here. And now what we do is when we have an infinite ordinal in here, we can diagonalize this guy here. So this guy turns into a 2. And now we can turn this into a psi 1 function of epsilon omega plus 1. And I basically did this in one step. I turned this into this, and then this diagonalized into omega to the omega. So just a little note there. Diagonalize again. We replace this with psi 1 of 0. That happens there. And then this turns into psi epsilon omega plus 1. Diagonalize again to get this here. Psi omega to the omega. Diagonalize again. This gets replaced with psi of 0. That happens there. And now psi of 0 we can change into epsilon naught, which as we know, diagonalized to 2, just turns into a 2. So this guy here just changes into a 2. Now at this point, I just broke this little bit off to work on it because we don't need to keep on writing this whole thing when it's going to stay the same for a very long time. So a little deconstruction of this guy here gives us psi omega times omega, because we basically just broke this omega to the power of 2 into omega times omega. We can then replace this guy when we diagonalize with psi of 0. It turns into this. This is epsilon naught when diagonalized to 2, turns into a 2. So we get omega times 2, which is simply omega plus omega. Diagonalize again, turn this guy into a psi of 0. Epsilon naught turns into a 2. And now we can use our rule where we can call this an infinite power tower of the previous psi function, which is psi omega plus 1. And the second element of the fundamental sequence is power tower 2 high. So we get psi omega plus 1 to the power of psi omega plus 1. And we do the same thing to this guy, basically. We call this psi of omega in an infinite power tower. Take the second element, which is 2 of these guys right here. We diagonalize this by inserting a psi of 0 in this slot right here. So we get psi of 0. This is epsilon naught, which turns into a 2. We do another tower here of 2 of the previous psi function. So we get psi 1 of psi 1. This turns into power tower of 2 of psi 0. And then this would turn into a 2, etc., etc., etc. And you can kind of get an idea of where to go from here. So this is an example that really covers everything that we've done before. It includes all the entire family of the psi functions. It includes what we do when we have a number inside the function. It includes what we have when we have an omega inside the function. And this is pretty much everything you need to know if you're going to start to deconstruct these ordinals. So what's the next logical step with this? Well, now that we know how to include infinite ordinals in the subscript, there's nothing stopping us from including infinite ordinals themselves. Sorry, infinite ordinals themselves. There we go. I can speak, I swear. Into the subscript. So we can have something like psi sub psi of 0 of 0. Or we can have psi sub psi of 0 of 0 and start to create arbitrary nestings of these infinite collapsing ordinals. And we can even create a fundamental sequence that's psi of 0, psi of 0, etc., etc., etc. So basically we can create a new ordinal which is defined as an infinite nesting of infinite collapsing functions. So just for fun, let's make one last humongous number with this concept here. Let's call it f alpha naught plus 1. And this isn't the alpha naught that I alluded to before. I'm just going to call this this alpha naught. We can name things however we want. Diagonalize at 3 this time because we want a really big number. And we're going to define alpha naught as this fundamental sequence right here. So basically what's going to happen here is I added this plus 1 in here just so we get an even bigger number. Basically this translates into f of alpha naught of f of alpha naught of f of alpha naught of 3. This one here turns into the third element of the fundamental sequence up here, which is this here. So let's just deconstruct this guy right here. So we'd have f psi of 0, 0 of 0. Now psi of 0 is epsilon naught, so this would turn into f psi, and then we could do the deconstruction of this, so it would be psi omega squared times 2 plus omega times 2 plus 3 of 0 of 0. And I'll leave it at that. Basically, you can imagine this being a huge ordinal being plugged into the subscript, so this would be an even larger ordinal. Then you'd calculate this somehow, and this would get plugged into here, which means the number of nestings of this infinite collapsing function would be this huge output here. Then you have to do it one more time, basically. So this is basically my submission for a very large number, basically. And there are larger numbers than this, basically, but they aren't definitely not calculable or not countable either. This is dealing with countable numbers that can be constructed with this kind of method type of thing. So if you want, you can go further than this. You have all the tools, but I'm going to leave it at this, basically. This is the end of my knowledge. I hope you enjoyed.